we want to perform a multi-objective optimization instead of doing single objective. Now we will do multi-objective optimization. We will connect these objectives along with the energy simulation, the thermal energy performance, or the value for thermal energy performance. And here you can double click. You can see that it started to give you. I will reset, and now I can see that I have the daylight autonomy and useful daylight illuminance. So an important question that I get is that why I cannot see the thermal energy performance in the name here in Octopus. It's not working. No, it's working. But the problem is that in this case, in Grasshopper, now the hooked up value component does not contain number. If you connect it to a panel, it doesn't contain number. So once you run the simulation for thermal energy in addition to the daylighting, you will find a result. So now I will start running the simulation for for the thermal energy, so that I get a value for this number. So now I have a value here in the number. So again, I will double click on the Octopus and I will reset. So we now have values in all dynamic parameters. As you can see here, I have a value in the thermal energy performance. I have also values for both daylight autonomy and useful daylight illuminance. Now I will double click again and reset. And as you can see here, we have the total thermal load, the DLA and the UDI. And I will also add diversity parameters as a fourth objective. And as I told you before, you can adjust these issues, or just leave them like what they are at the default settings. And then I will start the simulation, or I will start running the multi-objective optimization, and then get back to you when it finishes a considerable number of configurations. So now I will stop the optimization from here. And I need to wait so that the computer or the laptop works again. So again, we will look back into the TT toolbox. In case you want to record the data during the optimization, you can use the TT toolbox, and here we will add the extra 2 objectives available here. So I will add here plus 2 and hook up this one as DLA and hook up this one as the UDI, and here I'm going to eliminate this. And you will need to set this again into true. Well, when you choose to set it into true, everything that was recorded before or saved before in the C file will be override. So you need to copy and paste it in another position so that you do not lose your data. So I want to mention that an important note that Octopus only minimize the objective functions. So that's why in this case, you can see that the value of the DLA and the UDI was multiplied by -1. so that it could be when it's when Octopus minimizes these values, then we will go to reach the highest value. And so here I will double click, and as you can see here, we have the useful daylight illuminance, we have the daylight autonomy, and the total thermal load. And here I will use the cam or orthographic and the camera, and here I can see that the total thermal load, I can bring the minimum one, which is in this position in terms of total thermal load. The minimum one is 25312, and the maximum one is maybe 36. So this is the minimum one. So I might mark this one, and again I will. You can reset your camera, and then I will use orthographic again. And here I will bring this side so I can see the daylight autonomy. Here is the optimal result in terms of daylight autonomy. So I might use again the camera and reset it. So I can see here, this is the value that has, again, I will get this down so that I could see the values for the daylight. Here, as I hover over one, I can see that the total thermal load, and I can see it's DL. So here I want to get the optimal result in terms of DLA. So I will check this one, and then use orthographic. And here, this one is supposed to be the optimal result. Again, I will. And again here, this one is for the DLA, which is which had the value of the value for the DLA is 14.1. So here this is 12.7. So this is the one that we couldn't actually select before, because Octopus is not working in smoothly, so you need to do some tricks and trials so that you could select what you need to select, and so that you could get the right graphs. So I will unmark this. Here we have the optimal solution in terms of total thermal load, and the optimal solution in terms of DLA, daylight autonomy. And here I need to bring the total solution, the optimal solution in terms of UDI, which should be in the bottom part. So in terms of UDI, it's going to be the same one. It's negative 13, which is 13.5%. And as you can see here, this one is lower. It's a negative 12, which is 12. So we have here the optimal result for both is the same. So now we want to bring what is called the trade-off. We have the Pareto front solutions. Pareto front solutions actually are placed in the corner, because with the more we come to the corner, the more we get the best results, because actually we will have in the corner the lowest total thermal load, we will have also the highest daylight autonomy, and we will have the highest UDI. And as you can see in the daylight autonomy, the highest number is negative 14.17, which is what we have here. And also in terms of the useful daylight illuminance, it's 13.5, the number here, and it's the same here. So you might find something in the corner. What is available in the corner is going to be the optimal solution. We should have a couple of, usually we have a couple of trade-offs, but in this, because we didn't run the simulation for a long time and we tested a very low number of configurations, we're having just we have one here, so I mark gene, and then you will actually again make this axis view reset this axis view, because this actually stands in the corner as much as possible. You can see here we have 296 and we have 29690, 11% for the daylight autonomy and 12% for the useful daylight illuminance. So let's now reinstate, for example, the trade-off. I will reinstate this solution, and actually all the simulations will start running. I want to do this. I want to run the simulations because I want to visualize the results in terms of thermal energy and daylighting. In case you don't want to visualize the results, there is no need to make the Boolean toggles turn it into true. You might turn off the Boolean toggles in the thermal energy simulation and in the daylighting. So we now will visualize the UDI. We have here analysis results, and I will hook up the UDI 102,000 here in the analysis result. And it shows the results regarding this. And I might also hook up, I will actually disconnect this and now visualize daylight autonomy instead. And that's here we are finished. I have showed you before how to visualize the thermal energy performance. So I hope you enjoyed these tutorials, and thank you for watching.